My name is Tyler Pumphrey. Today we're going to go over the Fermosa plastics fires in 2005 in Point Comfort, Texas. Description of the systems and products. They manufacture plastic resins, use furnaces to convert naphtha and natural gas into hydrocarbon mixtures. They contain methane, ethane, propane, propylene, and many other chemicals. They use distillation columns to separate liquids using their exact boiling points. Many chemicals have different boiling points. Gases are then sent to storage containers after they are separated and liquefied. Some gases are used to fuel on-site furnaces, while other gases are recycled into feedstocks. Relief valves are located on distillation columns, heat exchangers, etc. These are in place to prevent the pressure from becoming overpressured and thus leading to an explosion or a fire. Valves move discharge to flare header system to safely burn hydrocarbon gases. This prevents the devastating accidents occurring that may come about when chemicals are discharged. They produce polyethylene pellets for its customers to be sold to other companies. They produce multiple other products such as plastic dishware, containers, toys, and many other plastics. The facility location is in Point Comfort. The location was selected due to its linear, low-density polyethylene plant. This is subject to plant-wide energy efficient assessment due to its being the largest energy consumer in the entire corporation. Operation and maintenance of organization, personnel, and procedures. Main production uses polymerization, process converting ethylene into a useful, stable polyethylene powder. Powder is mixed with additives and fed into an extruder. Extruder is a system used to create objects with a fixed cross-sectional profile. Powder is then heated and forced with a die. This is then set up to produce plastic pellets. Vehicles were used to move the final product. No type of impact protection on piping within open areas were implemented. Grounds were not set up to prevent vehicles from going in high hazard or high risk zones. Safeguards used. Administrative procedures. Plant-wide speed limit on all motor vehicles. Vehicle permitting process. Procedures for safe use of cranes. Design map including specific areas for driving of all motor vehicles. Areas of impact causing explosion was not in a designated access way, meaning that there was an area that was not designated as a drive area, but a driver was still operating within those zones. Operator of impact vehicle assumed safety in passing through pathway. Plant guidelines implied that protective measures should have been in place to protect operating equipment from such an impact. Fermosa management and safety engineers failed to provide adequate precautions. Recommended hazard controls. Ensure barriers are in place to prevent vehicle entry into hazardous zones. Plant initially had a plan, but failed to place appropriate barriers on site. Barriers should have included signs directing the flow of traffic away from unsafe areas to operate within, signs directing flow of traffic away from areas where piping or ground protrusions could impact vehicles, concrete poles to prevent vehicles from accessing hazardous areas, isolation of equipment to ensure piping be shut down immediately as a result of an incident or explosion, etc. This was not in place when that incident happened, therefore caused the accident that concluded from the event. Fermosa's lack of appropriate safety measures. Leak occurred between manual block valves and remotely operated control valves, making it hard to access where they needed to shut off. Arrangement of piping made it difficult, near impossible, to access the shut-off valves. Shut-off valves would have stopped the flow of chemicals in the area where the leak occurred in the distillation column. Operators were also unable to reach local control stations. This was due to the cloud of fumes being produced by the toxic chemical polyethylene. Having a remotely actuated valve installed upstream could have ended the disaster much faster, causing less damage to the facility. Recommended safety measures. Center of Chemical Process Safety, CCP, recommended guidance for vehicular traffic protection, remote isolation into the next revision of the Center for Chemical Process Safety's guidelines for hazard evaluation procedures. Therefore, they needed to see what they did wrong to be able to correct what they could do next time. The Occupational Safety and Health Administration, OSHA standards, 1910.132, interprets and explains PPE requirements for fire retardant PPE. PPE should always be worn where it is needed. They did not have the appropriate PPE in place to prevent employees from getting burned. They did have the PPE, but it was not being utilized properly. National Fire Protection Association, NFPA 2113 standards on selection, care, use, and maintenance of flammable resistant garments to protect industrial personnel against flash flames. They have the standard out that's supposed to show you and tell you how to use and clean and maintain these appropriate PPE, yet the company did not have them in place or was not using them appropriately. The American Petroleum Institute, API, PR 2218, guidance for proofing practices or for fireproofing practices and petroleum and petrochemical processing plants. Had the plant used this processing in their implementation of the process, they would have likely caused the accident to be less severe than what it was, therefore would have slowed down the leak and stopped most of the damage that occurred.